Okay, Assalamualaikum warahmatullahi wabarakatuh and a very good morning to all. Okay, today I will be doing the next chapter for programming techniques, which is chapter 7 pointers. Hopefully you guys can stay with me until the end of the video. Okay, so before we start, okay, we'll understand the objectives for today. So here in this week, we will focus on understanding pointer variables, and I will introduce to you the following concept, which is the pointer. What is pointer? Pointer of different data type, the address of operator and dereferencing operator, and also arrays of pointers. So pointers are variables and it follows the normal rules of regular variables. So pointer is a variable that stores the address of another variable in computer memory. So means that a variable that refers to another variables. So there are two operators in C which we use the n symbol, which represent the address of operator, and also the star symbol, the differencing operator, which I commonly use the value referred to operator. Okay. So for defining the pointer, okay, it's very simple. You just either, for defining at the beginning whether a variable is a pointer or not, you need to put the variable name with a star symbol. So if you use a pointer, the variable pointer here is recognized as a pointer by using the star symbol. If you don't have the star symbol, it counts as a normal variable. So when you assign the value of pointers, okay, pointers can point to only the variable of their own type. Means that if you use an integer pointer, you can only point to an integer. If you use a float pointer, you can only point into float. So even though pointers only consist of the address of variables, it is important for you to know that the data type represent the value of the variable that it's being pointed to. So it need to be the same type. Okay. So for example, here you have integer x equal 547. Okay. And here integer pointer. Okay. Integer pointer is equal value the address of x. Okay. The address of x. So pointer here is representing the address of x. So in the computer memory, when you store the data of X, okay, inside an address location inside the memory of your computer, the data is 547. And the pointer stores the data of the address of X. So here, 400 is the address of X. So next time when you run the value of what is this pointer to, okay, you can look into the value of the pointer by understanding that the pointer holds the data of X, which is the original data here. So in this case, when you initialize a pointer, okay, like for example here, integer X, num, and pointer, here you have three types of variable, and this variable, the third variable pointer, is a pointer. So X is 547. Pointer is the address of X. Okay. Num is a value of pointer. So to when you want to initialize, okay, you need to put the star. However, when you are using the star in any equation beneath the definition, it represents the value that the pointer is pointing to. So means that if you are pointing to you are doing, like for example, num is equal to the value of pointer. So pointer is the address of X. So the value of X is 547. Therefore, the value of pointer is 547. So this is the way we use pointer. Okay. So num is referring to the value of pointer, which at the end pointing to the value of X. Okay. So you can have multiple. It's kind of like a little bit twisty when you understand it. It's a little bit confusing. However, when you look it step by step, you can understand that it's just a reference to another variable. So this is an example here. Okay, you see that I have, okay, integer pointer m is an x equal 567. M represent the address of x. So that's why here is a pointer m. because M is holding the address of X. So when you want to print the memory address of X, okay, so you use the address of X. Okay, when you want to print the value of M, you use pointer M. So let's try this in code blocks. Okay, so let me demonstrate to you what happened. Okay, I have this code here. Okay, hope you can see. Okay, so let's take a look on this code. Okay, when I run this code, okay, so where is, I think I have this wrong symbol. Okay, then where is the wrong one? Oh, we don't need get character. Just need to close min. Not just putting get character. Okay, so let's run it. What happened here? You see that the memory address of X is 6356728. Okay, this is the memory address. So if you refer to the memory location inside my PC is this number, and the M is a pointer that contains the memory address of X, which is this one, and the value at X of is 567. So this 567 is being stored in this memory location here. Okay, and M here is pointing to this. The value of M here, okay, is the address of X. Okay, so the value of X is 567. Yeah. Okay. So here, okay, explain the meaning of each of the following declaration. Here we look at integer pointer A, pointer B, C. So pointer A and pointer B is a pointer that pointing to a certain address value. Okay, and C is a variable. So maybe C, pointer A, pointer B is pointing into the address of contain address of C. Okay, so because C is the one that holds the data. And then here we have pointer F. And here is character with pointer D, and E here is a normal character variable. Okay, so here for each and the following, write a statement that perform the indicated task. Assume that floating point variable num1 and num2 are defined and that num1 is initialized to 20.5. Okay, so let's try and do this exercise. Okay, so I have here. Okay, let's take a look at this code. Okay, so here I need to define the variable num pointer to be a pointer of variable type float. So we just define it according to float num pointer. Okay, so put this one, and then you have two floating point variable float. Okay, let's use the top one, num1 equal with num1 and num2. Let's make it like this, num2. And we make it num1 is equal to 20.5. Okay, so here, after we define the variable num pointer to be a pointer variable type of float, let's go towards number 2. Okay, for number 2 here, so address the of variable num1 to pointer variable num pointer. So here, what you have to do is you just put in num pointer, also is slash p, tr, okay, num pointer is equal to, suppose space is bad, pointer equal to the address of num1. Okay, so next, number 3, print the value of the variable pointed to by num pointer. So when you want to print in the value, you just put in printf value by num pointer. Here we just put in value of point num pointer. Okay, so don't forget to put in the percentage, no, %f, since we are using float. So dot two if, make it shorter. Okay, okay, then we do next one is assign the value of variable pointed by num pointer to variable num2. So here what you need to do is you put in num pointer num2 is equal to the value of num pointer. Okay, so and then print the value of num2, printf value of num2 equal to percent dot 2f, which is the value of num2. Okay, and then print the address of num1, use the %p conversion specifier. Okay, so here okay, let's try and run it. Check first whether I correct or not. Okay, so let's make it. Okay, then the last one, print the address stored in num pointer. Okay, so we use the %p again to show the address. Okay, address B/n. Okay. Since we stored the address in num pointer, so we did not need to change to put an n here. You just want to verify whether it's the same one or not. Okay. So this is the results. You can see here, value pointed by num pointer is 20.5, which is num1 value. And the value of num2 here is, okay, num2 here is the value contained for num pointer, which is the same 20.5. And the address of num1 is this one, okay, 0060FEF4. And the address stored in num pointer is the same one as the value of num1, the address of num1. So why is it contain alphabet here, FEF? Okay, so this one, the address shown here is stored in hexadecimal. Okay, shown is hexadecimal. Before this, when I show you the address is in decimal, here is in hexadecimal. So if you use to represent address inside a computer, usually they're represented by hexadecimal. Okay, so sometimes, okay, we don't know what kind of sometimes we don't know what kind of pointers we are going to represent, what kind of variable that we are using the pointer to point with. So in this case, usually we declare the pointer to be a void. A void means it can be anything. It can be integer, it can be float, it can be characters. So as long as you use as long as you have void to define the pointer, you can use the pointer as many time as you want, okay, to represent any data type that you have inside your codes. Okay, so basically you just put it if you want to make sure that when you display the data is displayed correctly. So you can just insert, okay, this bracket type pointer inside a bracket for the pointer itself. Okay, like this one. So when you insert this bracket, you can represent any when you use the pointer to print some result, you can have it print out as displayed as the data type that you want according to the definition what type you have. In this case, the pointer is pointing to an integer. So I want it to display the value using an integer as an integer. So you change the data type here inside the bracket. So the content of the pointer can also be manipulated by expression, okay, which is like plus, minus, minus, equal, okay. And also you might have a relational operator, okay, equal, okay, or less equal, more or less. By using this, you can save your time, okay, in case you have to change the whole code. You want to change a variable, but you don't want to change the whole code. So you want to change just the variable content. This is beneficial when you use pointer because pointer you can reuse it as many times as possible, okay, without interfering with the original data. So in case you want to change the data, you can just change the definition of the data without interfering with the rest of your code. Okay. So however, manipulation that involve the value of variable pointed to by pointer, okay, is not restricted to the previous operator. Means that if you change the pointer using to use it to another you use the same pointer for another variable, okay, the previous stored data will not be interrupted. It count as usage for a new variable. So that type of manipulation is treated as same as any manipulation for normal variable. Okay, so pointer manipulation involving its content address is treated differently from manipulation of pointer differencing. So we have manipulation of address itself. We want to change the address like addition or subtraction of the address is possible. Okay, but the way it treat the address is different than we treat the value of the address. So some of the valid expression here, okay, as you can see, we have x equal 0.1 plus 5. Okay, 0.1 plus 5. So 0.1, what is 0.1? Okay, 0.1 is address of 0.1. Okay, not the value contained in 0.1. So this is a valid expression. Okay, pointer 2 plus plus means the address stored in pointer 2 plus plus. Okay, you have addition to the address. And here, Okay, the value of pointer 2 divided by the value of pointer 1 equal x. So the value that is being pointed by pointer 2 divided by pointer 1 is equal x. So and then here address that's stored in pointer 1 is less than address that is stored by pointer 2. Okay, these are some of the value expression that you can use, but usually this is being done by a high level, very serious high level programs. Okay, so here, okay, let's play a game. Trace the output. So let's just copy this game, these codes here. Let's guess what kind of output is being shown here in the code. Okay, now in the printf here, printf area, it shown here that you want the value of y. Y equal percent y. So here we have the value at the beginning x equal 5. So what is the value of y actually? So x equal 5, z is pointing to the address of x. Okay, y is equal the value pointed by z pointer plus 9. So the value contained by z pointer here is 5. So 5 plus 9 is equal to 14. So let's check, am I correct? Okay, let's try and run the code. So as you can see here, y is equal 14. So my guess it was correct. Okay, so let's take a look a little bit more. So this one is a sample of pointer expression here. You can see that value 1 equal 100, value 2 equal 250. Pointer 1 is address 1, address for value 1. Pointer 2 is address for value 2. Value 3 is equal value pointed by pointer 2 plus value pointed by pointer 1 divided by 10. This one is equal to 250 for value 2. Okay, plus 100 divided by 10. So the answer is 260. So next, we go that value of pointer 2 is equal to the value of pointer 2 minus 7. So value of pointer 2 is 250 minus 7 is 243. And value 3 is equal value of pointer 1 divided by value of pointer 2. Pointer 1 is 100 divided by pointer 2, which is 250 plus 30 is equal to around negative 120. So this is the answer, this is a correct pointer expression shown here. So there are a lot of programs that use two numbers as pointer. Okay, like for example here we have integer a, b, r. So we have pointer a, pointer b, pointer r. So you can enter any number. Okay, so here you can see that scanf is using PA, pointer A, and not using NA. Okay, it's using pointer A. Why is it using PA instead of NA? Because PA is represented by NA. So it's the same. So you don't have to worry about the N. So you can create, when you create a pointer, it's the same as address of A. So scanf here, okay, for PA is equal to NA. Okay, same with PB. Okay, here you see that the value of PR equal to value contained in PA and value pointed by PA and value pointed by PB. So when you get addition, okay, when you get addition, you can display the result here. Okay, so here first number 15 and the second number 51, and you get the answer is 66. Okay, so we have a lot of change variable game. Okay, where you change and you guess what kind of answer is it. Okay, what kind of is the result shown in the printf. So you can try and do this in your lab session. Okay, we have a lot of fun with pointers here. Okay, we change the position, pointing, change from here to pointing here, till here to pointing here. So we change the value around with pointers and we guess the results. So this is where pointers is quite fun. Okay, at the beginning it might sound confusing and frustrating, and then I like to play game with students where we do the class with computer science student where we guess the output, whether you understand how computer works or not, how pointer works. So we guess the output here. So here, okay, after at the beginning, we have 6820. Okay. So ABC is 6820 and at PQR also 6820. So after they change a lot, okay, times here at the beginning it was 6 and 2. And at the end, you can produce this result based on just manipulating the pointers. Okay, so one pointer can point to many variables. Okay, so it depends on the latest one. The value point by the pointer is changed by the latest code, latest line of code that represent the changes of the pointer. So here we have multiple pointers representing a variable here. Okay, you can use multiple pointers just to change a variable. Note that if you change the value of a certain variable, like for example, in this case, you change the value of P, Q and R also will change because original value is A. Okay, so if you change the value of PQR, it will change the A. Okay, and a little bit more confusing is that pointers can also point to pointers. So means that it's a pointer for pointer. Okay, so this one it goes two or three level more. Okay, like for example, Y is representing address of X, Z is representing address of Y. So here you have a double pointer. So here pointers that pointing a pointers, we call it double pointer with two stars representing it during the definition. Okay, and sometimes we can go up until three stars. So means that it's a pointing to a pointer that point to a pointer that points to a value. Okay, so three times pointing. Okay, so I provide a list of codes uh, in your column so that you can refer to those codes later on. Okay. Okay, so for array, so array a pointer is also the same. Okay, so is the difference is that when you use array with pointers, you need to define the array location, whether it's column or row properly, like you define other variables. Okay, so here you can try and represent the pointer according to the number of the pointer. So for example, value of pointer B, okay, plus I. So I means which index is it? Okay, as long as, for example, you want to show the value of the pointer uh, for B in the second row, you have to use it as, okay, BPTR, okay, BPTR, pointer B, okay, BPTR plus I, okay, in this case plus I. So we have a lot of exercise for you to do this week just to have fun with it. So this is one of the exercise. So make sure that you try in our lab session to finish all of those. I'll see you guys later on in the next class. Thank you so much for watching my video and I see you guys later. Bye.